What's up, guys? You're on GCSE and IGCSE revision. That's exam starts questions prepared especially for you. That's percentage problems from easy, medium, and to the hard level. We've got 3 problems to go through. Hope it's gonna be very helpful for you. And right now, I just want to show what we've got here. That's the easiest one, problem 1 for year 9, basically. Here's problem 2. Also try to fix it. It's sort of medium level. And the hard problem 3, that's what I consider definitely hard because you need to be able to analyze data, to work with, logic here, and also use discount formula, all right? So if you're ready, let's just start working on, but of course you need to do by your own and then compare it with my explanation. That's always works in this way. Alright, so let's discuss problem 1. You have travel competitions and you have 35% of participants travel less than 150 miles. Alright, so that means 35% stays for those who travel less than 150 miles. Obviously, the rest part, which is 100 minus 35, which is in its turn, is going to be 65% stays for those people or for those participants who travel more equal than 150 miles. All right, so that's our boundary numbers. Okay, so we need to find the difference between number of people who traveled 150 miles or more. So that means from those people which represent 65% out of total amount of participants, so 1,200. So that means we need to take 65% of this number. So that means what I recommend to do is to convert 65 into fractional number and then, or into decimal, and then take it out of your amount of participants. So that number will represent number of participants traveled more equal than 150 miles. Okay, and you want to find the difference between other people, the rest people who travel less than 150. So less than 150 is 35% as the rest number. So I would recommend do the same. 35 times 1,200. And that's going to be the rest part, less 150 miles. Okay, so that's the difference, and that's the question, primary question here. So what we can do, we can take or grab calculator and calculate, but I would simplify a little bit. I would factorize 1,200 and I just have 0.65 minus 0.35. So that means we'll get 1,200 times the rest part, which is 0.30. All right, and now you can grab calculator and calculate. So that's going to be much pretty easier. So 360 people. All right, so that's the difference. And if you're set up in other questions, how many people exactly travel, let's say more equal than 150 miles, you can work out. So but here I decided to set up a bit weird questions in order to make you guys a little bit confused. All right, so this problem is basically for those who are on year 9, and we'll move to the next one. So all right, so here's a problem 2 when the speech is about borrowing money. It's interest free because of relatives. Okay, he borrowed from his relatives, and that's sort of friends. All right, and that means he's not supposed to pay any interest. University education is good, and he pays 3.31% of the amount borrowed quarterly. Okay, so first of all, we need to calculate for how many months has he been paying back those $35. So we need to calculate for how many months has he been paying back this amount. Okay, he paid today, just recently, and we need to calculate from the starting where he borrowed up to now. Okay, so what we can do, we can simply calculate 3 and 3 recurrent, because that's 3 1 over 3 percentage right now. we need to calculate out of 210 pounds. So we calculate, we understand the their quarterly amount paid on quarterly basis, basically. So what we can do, we can convert into, I think, into fractional number, or just if your calculator allowed to input recurrent decimals, so you can use that, but I would prefer to do this way. So 10 over 3, and this is percentage out of 210 pounds. So that's what I'm going to do. So I'm taking 10 over 3 times 210, and finally I would like to divide this whole by 100. All right, so right now I can say that it's going to be 7 pounds. All right, so 7 pounds per every 3 months, right? Because in quarter there are 3 months, because there are 4 quarters in a year, so that means you have over 412 over 4. That means you'll get 3 months per quarter. All right, so every 3 months he paid 7 pounds. All right, now if it turns out to be 35 up to now, so how to calculate number of months is, we simply do the following: 7 times 3 is going to be, we can do the following: 35 pounds. Yeah, we can divide by 7 pounds. In this case, we can find number of quarters. In this case, we have 5 quarters, or multiply by 3, we'll get number of months. So it turns out to be 15 months. Okay, so 15 months of payment, and that's is going to be the answer for the first part. So up to now, he has been paying for 15 months. Okay, so part B, find the number of months left to repay the loan in full from now. All right, so right now, up to now, so that was 15 months before. He repaid 35 pounds, and this is now. So this moment is now. Okay, and from now and on the following period, the number of months is for the residual amount. So residual amount is 210 pounds minus 35 pounds. So that's how we can find the residual amount to repay, and I guess it's going to be 175. So 175 pounds you need to repay. So we know that every quarter or every 3 months he needs to pay 7 pounds. Right now we can simply divide the residual amount left to repay over 7 per 3 months. All right, so let's try to do. So we divide by 7, and it's going to be 25 quarters. Okay, and right now what we need to do, we need to multiply by 3, right? Because we need to calculate number of months right now. Okay, so we multiply by 3. That means we calculate number of months, and 3 by 25 is going to be 75 months. All right, so that's pretty much great periods. So left to repay. Left to repay in full, 75 months. So if you want to convert in terms of number of years, so what do you need to do? 75 over 12, so it's around 625 years to repay. So it's quite a big period. So if interest free, it's a very lucky bargain. All right, so make sure. All right, so that's around like bachelor degree, master degree, and probably PhD. All right, if you take into account the previous 35 repeat. So all right, we're in problem 3, and here we need to define how many days before the departure this person actually purchased his ticket. All right, we need to understand that the more days before departure, the more discount you have. So where's the key sentence here to analyze actually for how many days actually before departure did he buy the tickets? Okay, so what I consider as the following. So let's say this is the timeline, and let's say there's number of days before departure. So what I can do, I can set up departure day right now. So that's going to be departure. So this instance of time is going to be departure. And here a number of days that he actually bought the ticket before. All right. So the key sentence, as I said, this one, had he bought the ticket a day later, he would have paid 320 more. So obviously this sentence indicates that he bought at the boundary, somewhere in between those like gap in discounts. So that means if I set up a certain boundary between the price, between the period where you have, let's say, one discount and another one. So I put R indicating discount rate, and that means he bought the ticket somewhere here, just at the boundary, and just one day later, I mean closer to the departure day, the discount rate should be lower. All right, so that means if I indicate R, the rate he actually discount rate he actually has, okay, and R1 is just one day later. So we can state that the rate that he bought a ticket for is going to be higher than the rate one day later. Okay, so that's one day later, and this rate is actually the day of purchase. All right, so for simplicity, I put, instead of P0, initial price without discount, so initial price with no discount, and so we're looking for the following. So what we can do, we can set up one more column that where we have the difference 100% minus discount rate, but I would convert immediately into decimals by divided by 100 everything. So that's going to be 1 minus R. But if you like, here I just could put the amount in percentages. So why? Because I will set up the following equation. So what I'm going to do, I'm going to do the following. So we have the amount he paid for the trip. It's going to be £1,600, and that's for discount he actually had at the day of purchase. So basically R. How discount works, you need to subtract from 1, but R should be converted not in percentage but into decimal. So this is decimal rate. So we multiply by the amount of the original initial price, P0. That's how we normally apply the formula for discount. All right, so that was the price he actually paid. Now if here purchased the ticket later on, one day later, he would pay 320 more. So right now we just calculate 320 more, and that means this amount is going to be 1,920. Okay, and how it works in terms of discount is going to be 1 minus lower discount, because obviously the price is higher. That means it's going to be R1 is going to be less than R. So apply it to the same price P0. And what I can do, I can divide. So because that's simultaneous equation, I can simply divide to eliminate the original price. If I divide that, I'll get the ratio So it's better to divide the equation 2 by equation 1. So we divide in equation 2 by equation 1. And right now the result is going to be 1920 over 1600. So if I do that right now, we'll have the ratio 1.2. Okay, so this ratio is 1.2. And here, because P0 and P0 will be cancelled, we'll left with 1 minus R, and here 1 minus R1. Okay, so now, how exactly to understand within which period it was done? So we simply can figure out 1 minus R difference as like very helpful column here for us. So why it's helpful? Because we're going to track right now the difference between 1 and the rate converted into decimal. So we're going to have in decimals as a decimal. Here we're going to have 1 because 0% is still 0. So here it's going to be 90%, but it's going to be 0.9. Here is going to be 0.75, and the last one is going to be 0.70. And right now we just need to find the ratio 1 minus R to 1 minus R1, the previous one. So the rate or discount for the previous period. For example, what we can do, we can compare the first pair. It's going to be 1 to 0.9. So right now, what I'm going to do, I want to take the ratio. So 1 to 0.9 in order to say what we have right here. It's going to be 1.2 or not? So now what we're going to do, the strategy, we need to get exactly 1.2 ratio between adjacent discount periods. Okay, so we're going to divide 1 by 0.9. So we get around, and just put it down. So we'll get around 1 and 1 recurrence. So that's close to 1.2, but it's not actually. So let's take another pair and divide 0.9 by 0.75. So right now we'll have 0.9 by 0.75. We'll get exactly 1.2. And just for comparison, let's take 0.75 to 0.70. So that definitely say that right now we are in between two zones, and actually what we're looking for, because we got 1.2, the same ratio, and just finally 0.75 over 0.70, we'll get around 1.07, smaller. Okay, so right now that's definitely, it was the purchase was made in between 1521 days period and 814, somewhere in between. How exactly to get? So that was the day of the purchase as we understand. So right now I just want to highlight. So that's where we're looking for our solution. How many days before his departure? Okay, and right now we understand that this is going to be rate 1 and, sorry, the way back. There's going to be a rate, and that's going to be rate 1, okay? Because it turns out that he bought 15 days before, while plus 1 day later, it means 14 days. So he would pay those 320 more, okay? That means rate, and rate 1 was 14 days. So the actual answer was 15 days before. Okay? So that's how it works. Hope you like that. That was percentage problem. And see you next time.